Okay, so one last quick question. Draw the Lewis structure for CH4O, in which oxygen is bonded to two kinds of atoms. Do not consider cyclic ring structures. That's helpful. So first, let's find the total number of valence electrons for this molecule. Carbon has 4, and hydrogen has 1. And there are 4 hydrogens, so we multiply this by 4. And oxygen contains 6. So if we were to add these up, we get a total number of 14 valence electrons. So first, let's draw my carbon, and I'll have it single bonded to 3 of the hydrogens, and another single bond to the oxygen so that it has a full octet. And now the oxygen will also have a single bond to the last hydrogen. So if we count out how many electrons I've drawn so far, each bond contains 2 bonding electrons, and we have 5 bonds in total, so I only have 10 bonding electrons out of the 14 that I need for the entire molecule. So for the last 2 electrons, I can put them as lone pairs on my oxygen, since both carbon and hydrogen are satisfied already. Hydrogen can only form single bonds, and it can't have any lone pairs since it only has 1 electron to contribute, and that's used in the bond. And carbon already has a full octet, so that's why we put it on the oxygen. So this is the Lewis structure, and this is actually just methanol. So let's see what the junior tutor said. First, calculate the total valence electrons, so they got 14. Now connect all the atoms with single covalent bonds to draw a skeletal structure. Given that the oxygen is bonded to 2 types of atoms, therefore connect oxygen to carbon and hydrogen. So there are a total of 5 bonds, each containing 2 electrons, so therefore 10 are consumed for making the skeletal structure. The remaining electrons are 4. So place the remaining 4 on the oxygen. Step 4, if the octets of all the atoms are not filled, then convert the lone pair on the most electronegative, but in our case, they're all filled. Calculate the formal charge. So this is an extra step just to double check to make sure we have the smallest amount of possible charges. So if we were to calculate the formal charge for all of the atoms, you end up getting 0 for all of them. And then the final Lewis structure is shown below. All the atoms in the molecule have a formal charge of 0, so formal charge is not shown. Yep. So this solution is correct. Okay, so those are all the questions for this session. And if you enjoyed today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also you can leave a comment and give it a thumbs up if you enjoyed the video. And you can share it with your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.